In this video, we are going to learn the basics of bearings, its functions, how to select appropriate bearing for any application, how to rightly assemble different types of bearings, etc. If you are related to machine tool design, SPM design, machine tool maintenance, machine assembly, service engineer, then this channel will be of your help to improve your basic understanding about various machine tool elements and to excel in your works. Hi, this is your Machine Tool Academy, and we assure you to put our best effort to add value in your learning process. Bearings are widely used in most of the objects we use in our daily lives and have become an essential item to achieve smooth and energy-efficient operation. It also plays a vital role in machine tool building for its smooth function. Bearings are used to reduce friction between the parts which are in relative motion. By reducing friction, we are able to achieve higher speed, smoother operation, less heat generation, and lesser wear and tear of parts. Various types of bearings are used for different applications based on the parameters like type of load, accuracy required, load carrying capacity, speed required, life of the parts, etc. Before diving into the details, let us look into few basic technical terms to comprehend the need of creating different types of bearings. Point contact. When a spherical-shaped object comes in contact with a flat surface, only the highest point of the ball will touch the flat surface because of its geometrical shape. For example, let's us assume a ball resting on the table. Now this ball is touching the table only with its highest point. To further demonstrate this, ball is dipped with ink over a wide surface, and when we try to put it on a flat surface, we can see the contact area as a point. This is point contact. Line contact. When a cylindrical object comes in contact with a flat surface, the contact area will be a line as shown in the figure. To demonstrate, let's take a cylindrical roller, dip it in ink, and place it over a flat surface. The contact area is forming a line. This is line contact. As a result, the load carrying capacity of line contact is more compared to point contact due to the more contact area in the line contact. Similarly, the heat generation in line contact is also more due to friction of more contact area in line contact, and in point contact, the heat generation is less. In simple, more the contact area, more the load carrying capacity. Lesser the contact area, lesser the heat generation, and able to achieve higher speed. Surface contact. Consider a flat surface object which is coming in contact with another flat surface. Then this contact is called surface contact. Let's take an iron press as example. When we use the press on any shirt, the flat surface of the iron press comes in contact with cloth and transfers the heat in the entire surface, which is in contact. As a result, we get the impregnated shape of the iron press in the cloth. This is an example of a surface contact scenario. Because of the increased contact area, the load-carrying capacity of the surface contact object is more when compared to the cylindrical roller, which was creating only line contact. In the same way, the heat generation due to friction is also more. In simple, more the contact area, more the load-carrying capacity. Lesser the contact area, lesser the heat generation, and able to achieve higher speed. Sliding. When an object is made to slide on the floor, the contact surface of the object is opposed by the frictional resistance created between the contact surfaces. The force required to slide the object needs to be greater than the frictional resistance. Friction between the surface generates heat, wear, and tear. The frictional resistance can be reduced by few parameters like introducing lubrication, by increasing the surface finish, etc. Rolling. When, as shown in the figure, a cylindrical object is made to roll over the floor, you will find it very easy to roll by applying very little force. It is because the object need not to overcome the frictional resistance of the line contact, rather, it is rolling over an adjacent line of contact, comes into the picture, and go on. This concept is used in rolling element type bearings, which we will see in detail on the later part. Bearing types. There are many types of bearings in the market based on their working principles, elements used, material used, type of loads. However, it can be majorly categorized into 5 groups: plain bearing, rolling element bearings, jewel bearing, fluid bearing, magnetic bearing. Let's see all the bearings in detail one by one. Plain bearing. A plain bearing is a simple type of bearing that supports a rotating shaft. Plain bearings works on sliding principle between the shaft and the bearing surface. A plain bearing typically consists of 2 main components: the shaft that rotates and the bearing surface, which is usually a cylindrical sleeve or bushing. Lubrication is essential for plain bearings to reduce friction and wear between the shaft and the bearing surface. Plain bearings are used for heavy load carrying capacity and where higher speeds are not required. Rolling element bearing. If any rolling element is used between the bearing surface and the rotating part to reduce the friction and to achieve smother operation, it is called as rolling element bearing. The rolling element can either be a ball or a cylindrical roller. If balls are used as rolling element, then it is called ball bearing. And if rollers are used as rolling element, then it is called as roller bearing. It consists of the inner race, the rolling element that is balls or rollers, the outer race, and the retainer to retain the rolling elements in its position. Thus, smooth rotation is achieved while supporting the load. This ball bearing can be further classified based on the type of load applications, such as radial ball bearing, angular contact ball bearing, and thrust bearing. The radial ball bearing, which is also called as simple ball bearing or deep groove ball bearing, is used for radial load application, such as simple gearboxes, wheels, fans. Thrust ball bearing is used where the load application is axial. That is, load direction is in parallel to the axis of the bearing as shown in the figure. This type of bearings we can find in heavy-duty cranes, huge lead screws. When the load application requirement is the combination of radial and axial, then angular contact ball bearings are used. This types of bearings we can find in spindle assemblies, ball screws assemblies. Similarly, instead of balls, if the roller is used, that is called as cylindrical roller radial bearing, cylindrical roller thrust bearing, and taper roller bearing, respectively. Jewel bearing. The name jewel bearing is given because of the gemstone materials being used in this bearing. Generally, sapphires and rubies are used. Because of its high hardness and surface finish, these bearings are wear-resistant and long-lasting. We can commonly find these bearing usage in mechanical watches, compasses, measuring instruments, and other precision devices, where smooth, low-friction moment is essential. Fluid bearings. Similar to rolling elements in roller bearing, in this fluid bearing, a thin layer of fluid is used to separate the moving surfaces and to reduce the friction between them. There are 2 types of fluid bearing. 1. Hydrostatic bearings. 2. Hydrodynamic bearings. In hydrostatic bearing, a pressurized fluid is used to lift the rotating shaft and keep it in center. This pressurized fluid will act like a separator between the moving surfaces and hence reduce the friction. In hydrodynamic bearing, the relative motion itself will help the fluid to form a separator film around the shaft and hence reduce the friction. The advantages include low friction, high load capacity, smooth operation, suitability for high speeds, and long service life. It is commonly used in turbines, compressors, and precision instruments for their reliability and efficiency. Magnetic bearings. The magnetic bearing working principle is similar to that of a fluid bearing, but instead of the fluid in fluid bearing, it uses magnetic field to separate the moving surfaces and hence reducing friction. They offer precise control, high-speed capabilities, and low maintenance. It is commonly used in turbines, compressors, and high-speed machinery. They ensure stability and reliability. Thanks for watching. If this video is useful to you, then please like, comment, share, and subscribe. Meet you in our next video about how to assemble different bearings in various assembly.